Hello students, this is Mr. Duarte and I am going to be going over scale factors of similar figures. Remember, when dealing with similar figures, they stay the same shape but different size. And corresponding angles are going to be equal and corresponding sides are proportional. When we look at this first example, we have rectangle LO and M. We see that the angle measurements inside this rectangle are all 90 degrees, and that does not change for the image after. All 90 degrees. In this example, we are trying to find the scale factor given that rectangles are similar. Remember, similar figures have the same shape but different size. Corresponding angles are going to be equal. Even though not pictured, not marked, we know that these are all 90-degree angles and that they're all going to stay 90-degree angles. Now, to find the scale factor given side lengths, we're going to have to set up a proportion. So we see that the corresponding side lengths of this particular rectangle are going to be 10 and 25. We're going to divide 25 divided by 10, setting up a proportion, which gives us 2.5. Now to check that, we can go to our first pre-image. 10 times 2.5 should give us our new side length, and it does in 25. Now we can check it again, setting up another proportion. 15 divided by 6 gives us 2.5. Checking that, 6 times 2.5 gives us 15. There are a couple things to remember when using scale factor. Remember, scale factor is used to either enlarge or reduce the size of an image. Remember, that image is not going to change its angles. The corresponding angles are going to stay equal. Now, the only difference is if the scale factor is greater than 1, that means the image is going to be enlarged. If the scale factor is less than 1, it is going to be reduced. When given side lengths of an original figure and a scale factor, to find the new side lengths, you are going to multiply each side length to the scale factor. Let's look at some examples of enlarging or reducing scale factors. We see that 3/4 is less than 1, thus giving us a reduction. Scale factor more than 1 of 5 is going to be enlarged. Scale factor of 0.99, less than 1, reduce. 1.98, more than 1, enlarge. 2, more than 1, enlarge. And then we have an improper fraction of 8/3. Don't assume that just because it is a fraction that it is going to be reduced. With improper fractions, you have to figure out how many times does the denominator go inside the numerator. We know that 3 goes into 8 more than one time, thus giving us an enlargement. On your Google form, you are going to be given a shape with side lengths and given a scale factor, and you're going to have to find the new side length measurements. When given this, in this particular example, I am given GI as a measurement of 2 and given a scale factor of 3/2. I am going to multiply my side length times my scale factor, giving me my new side length. Doing it again with IJ, my side length is 4. Remember, when multiplying fractions, you multiply across, so 4 times 3 is 12. 2 goes over, underneath the 4 is an imaginary 1. 12 divided by 2 is 6. Also on your Google form, you're going to be given a shape on a coordinate grid. This shape will not have the side lengths measured for you. You're going to have to do that yourself by counting the squares of each side length. For this particular triangle, my base is going to be the 6 and my height is the 5. There is going to be a question like that on your Google form. I am going to be multiplying each side length by the scale factor, as you see right here. 5 times 1/9, 6 times 1/9, 8 times 1/9. Sometimes you will be given a question without a picture, but they will give you the side lengths and the scale factor they want you to use to create the new dimensions. In this particular example, it is a rectangle with a length of 6 and a width of 2, with a scale factor of 5. Now remember, with each side length, I'm going to multiply each side length times the scale factor. So I'm going to start with my length of 6, 6 times 5, which gives me a new length of 30. Then I'm going to go to my width of 2, multiplying that by my scale factor of 5, giving me a width of 10. On your Google form, you're going to be given side lengths of a shape. Multiply each side length by the scale factor given. In this particular example, I am given a shape with a scale factor of 3/4, and I am supposed to find the corresponding figure. So I'm going to start off with each side length multiplying by my scale factor. So let's start off with 10. 10 times 3/4 is going to give me 7.5. Now let's check the others. 8 times 3/4, 24 divided by 4, gives me 6, thus giving us C as the answer. Remember, when given a shape and the side lengths and the scale factor, and the question asking what the new shape is going to be, multiply each side length individually to the scale factor. On your Google form for the last two reflection questions, please be sure to explain what you would do when given side lengths and a scale factor. How are you going to find the new side lengths of the new shape? Remember, similar figures create corresponding angles that stay the same and corresponding sides that are proportional.